right, here we go. Today we're going to talk about something called the Law of Sines, and we're going to kind of go backwards on this one. Usually we don't save the ambiguous case until the very, very end because it's just so confusing, but to really master the law of sines, let's take a look at that ambiguous case. Side angle, or if you're dyslexic, it's a bad word. Here we go. In an oblique triangle, a triangle does not have a right angle. So you can see all the angles are either acute or obtuse. They still add up to 180, and when you label triangles again, little a is across from big A, little c is across from big C, little b is across from big B. Here we go. You'll recall from math analysis, from trig, from geometry, that the law of sines has the following ratios or proportions from the side to its angles. You can also flip it around, so one can also say that sine A over A is sine B over little b is sine C over little c. Either version of it will be the same as long as you have the same proportion. So angles over sides or sides over angles. Here's the proof. All right, here we go. P.S. Go ahead and feel free to pause the video to draw the picture and then continue when you're ready. All right, so let's say you're looking at side A, right? If we were to drop a 90-degree triangle, wouldn't you agree that sine A is equal to the height over B? So therefore, if you multiply by B, B times sine A is equal to the height from that point. At the same time, sine B is equal to the height over A, so A times sine B is equal to H. And by the transitive property, you could say that since they're both equal to H, B times sine A is equal to A times sine B. If you divide both sides by the sines, then you would get B sine B is equal to A sine A. That's how you show it. So, I mean, it's a pretty common sense property. The key is dropping that height. And that's where the ambiguous case comes into play. So, if you're given two sides an angle, the angle opposite them, which gives you the side-side angle, does this determine a unique triangle? Can we use it to use the law of sines? Well, it depends. This case is called an ambiguous case because we just don't know. We have to find out. There could be one, two, or even no triangles could exist. So that's why it's ambiguous. To find out, it's really simple. If you remember dropping that H, right, we can figure out how to find those triangles. So, for example, by the way, this is where you would use your little organizer that you should have got in class. If you didn't, it's okay. Just pause the video and draw yourself a little chart. Okay, here we go. Let's say the A is bigger than the height and bigger than the B. So, if the A is bigger than the height and bigger than the B, then a triangle should exist because it should complete the rest of the triangle. So you should get one triangle for this case. If the height is the A, then you have this case. And if the height is the A, then you would have one triangle, and it turns out to be a 90-degree triangle. There you go. If the height is bigger than the A, so if the triangle is taller and the side won't cover it, then you couldn't make a triangle. Therefore, no triangle could exist. And last but not least, as long as A is bigger than H, and it could be between B, so for this last one, you could say that H is less than A is less than B, puts these two together, then you could have another triangle as well. As long as A is bigger than H, you could have another triangle. If it's between the H and the B, then you know you could have two possible triangles because this A could also swing this way. That could be H as well. This is the ambiguous case where you can swing that side off to the other side. It'll still make sense. Okay, so in a side-side angle situation, the law of sine determines the number of triangles, if any, and gives a solution for each of those triangles. All right, so we're solving triangles today, but first we have to see if we even have a triangle in the first place. Let's take a look at example 1. Okay. Again, to figure out if you have a triangle, just go ahead and drop the height. So the question is, do we have a triangle? Using the law of sines, you can see that sine of 43 is equal to h over 62. So 62 times sine 43 is h. Make sure your calculator's in degrees. And so we can see that h is 42.28 degrees, which this is side A right here. Obviously, this is bigger than A. They're not equal to each other, but we do have one triangle that we can solve for. So as long as there's one triangle you can solve for, then go ahead and use the law of sines. We have side B, so let's go ahead and find angle B. Right? So here we go. Sine, I like to use find the variable, put that at the top. So you could go sine B is to 62 as sine 43 is to 81. So sine B would be 62 times sine 43 over 81. I'm being lazy and not putting the degrees. Sorry about that. And of course, if you take to find B, you would just take the inverse sine of 62 times sine 43 over 81, which gives you about 31.47 degrees. Start filling it in. So this is 31.47 degrees. As you can see, then the next easiest thing to find would be angle C. So angle C is equal to 180 minus angle A minus angle B. So 180 minus 43 minus 31.47 will get you about 105.53 degrees. It's a fairly accurate picture. Okay, and we need an angle C because we're looking for side C. And since it's not a right triangle, you can't just use the Pythagorean theorem and go a squared plus b squared is c squared, because that's not true when it's not right. So the last thing we need to find is side C. Again, I like to put the missing thing on top, so since we're looking for C, then I put sine C at the bottom, which is 105.53. And I'm going to go ahead and use the given side again. So 81 over sine A, which is 43. Do your magic, dot, dot, dot. You should get C is about, little c, 114.43 inches. And that, my dear friends, should complete our triangle. Pretty simple, right? All right, let's get to good stuff. We found one triangle. Let's take a look at example 2. Okay. First, we have to see if a triangle even exists. All right. Now, a little bit hard to see from this point of view, so let me change our perspective. Okay. So we're checking to see if the triangle exists. Okay, let me switch it around for you a little bit, so it's hard to see from this vantage point. Let's put the 15 down here. Okay, so that's C. And so let's put A, we're just switching it around, B and C. Let's see why for a second. I needed to drop the height from the A, and it was kind of hard to do from that perspective, so I needed the height. AC is 17, and then AB is 12. So we're going to check to see if we have a triangle. Sine 15 is H over 17. So 17 sine 15 is equal to the height. And that's going to be 4.4. And as you can see, the numbers are 17 and 12, so A has to be like around 17, between 17 and 12. So therefore, it is greater. Little a has to be bigger than 4.4. And since it's bigger, you got two triangles. Uh-oh. Okay, here we go. Triangle number 1. Let me insert a page. Okay. Okay, for triangle number 1, let's just go back to that original picture. You have A, B, C, 12, 17, and 15. Right? Since we have the 12, we can use law of cosines to find angle B, the 12 and 15. So the missing part is sine B is to 17, as sine 15 is to 12. So sine B is equal to 17 times sine 15 all over 12. Right? And if you take the inverse of it, the inverse sign, you're going to get angle B. And actually, I should call this B1, right? The first B, because there's going to be a second one, is about 21.50 degrees. Okay? Since we have angle B, that's the first thing, then you can find angle A, which is just 180 minus angle B minus angle C, which if you subtract all of that, you should get 143.49. Stop the video and check my calculations for me. You guys should have calculators out. Okay? And the last missing part would be side A. So A is to sine A, as we're going to use the given side again. For 12 is to sine 15. So A is equal to 12 times sine 143.49 degrees divided by sine 15 degrees, which puts us at about 27.585. So that's 1, 2, and 3 things that we need to find for the first triangle. Okay, so let me draw a picture of that first triangle, a more accurate picture, right? So we know that sine C, well, angle C is 15 degrees. And angle B is only 21 degrees. So that's acute. So what happened was, since this is 21 point something degrees, angle B could also switch over to the other side, right? So this is angle B, it's pivoting, so A could be here, this is A1, or we can move A2 to the other side. And to do that, all you have to do is take away the 21 point something degrees from 180. So let's take a look at angle 2. Right? It's triangle number 2. Okay. So again, to find the second possibility that B could be, just take 180 minus B1. So 180 minus 21.510. So the second possibility, the angle B could be, is 158.49 degrees. So angle A, 2, is 180 minus B2 minus C. C is stuck. Okay. And if you were to subtract all of that, you would get angle A to B 6.51 degrees. Again, pause, check, make sure I'm good. Okay. So the third thing you need is baby A. So baby A is to sine 6.51. Keep the C's. So C is 12 over sine 15. So A is 12 times sine 6.51 degrees. Being lazy again. Over sine 15 degrees. So A2, I should say, is about 5.257 units, whichever. That's 1, 2, 3. All those 3 parts. The 3 missing parts for that triangle. Told you this was going to be fun. All right, so we did 1 triangle. We did 2 triangles. The last case is no triangles. Yeah. Here we go. Let's take a look at this one. All right, so we got triangle ABC. Okay. We have angle A is 75 degrees. Side A is 51. And let's say this is where B is 71. And let's just call C it right there. Okay. Again, check to see if there is even a triangle. And I already told you there's not. Here's why. For the H, sine 75 is equal to H over 71. Multiply 71 to sine 75. And you got H is 68.58. And A is 51, right? This is A. That's obviously bigger than A, so no triangle exists. And they all lived happily ever after. Good luck with your homework. Text me anything, any pictures of problems that you can't get. I'll be around on Remind 101 to help you as best I can. Good luck, everyone.